All right, today we're cracking open the architectural blueprints for a really modern, high-performance object storage system. It's called NexusStorage. Let's dive in and see what makes it tick.
That's a really fair question. With so many storage options out there, why on earth would you build a completely new one from scratch? Well, the answer is actually pretty simple: to hit a level of performance and modern design that the existing stuff just can't touch.
And here they are, the key objectives that really drove its creation. NexusStorage was designed with 4 big goals in mind. First, just blistering performance, getting as close to the raw metal speed of the hardware as humanly possible. Second, extreme durability. We're talking 11 nines of reliability. To put that in perspective, that's like a few seconds of downtime over 1,000,000 years. Third, seamless scalability, so it can grow without any drama. And finally, a modern foundation, built on the latest .NET 10 runtime.
So how do you even begin to achieve goals that ambitious? Well, you start with a solid blueprint. And for NexusStorage, that blueprint is a really powerful design philosophy known as clean architecture.
So what exactly is clean architecture? Well, think of it like building a house where the plumbing and the electrical systems don't care what color you paint the walls. It separates the most important business rules of the system from all the nitty-gritty details, like databases, frameworks, or APIs. And this is huge because it makes the whole system way easier to test, maintain, and evolve over time.
NexusStorage brings this whole idea to life with 4 very distinct layers. At the absolute core, you've got the domain. This holds the essential building blocks, things like object and bucket. Wrapping around that is the application layer, which coordinates specific jobs, like a multi-part upload. Then comes the infrastructure layer. This is the real engine room that does all the heavy lifting. And finally, on the very outside, you have the presentation layer, which lets the outside world talk to the system through APIs.
This visual really shows you the power of that separation. See how the core rules in the domain are completely insulated? The S3 gateway, way out on the edge, only has to talk to the application layer. And that layer, in turn, manages the whole process without needing to know the low-level details of how data actually gets written to a disk. This design is the secret sauce. It's what makes the system so stable and so easy to maintain in the long run.
Okay, now let's go deep. We're heading into that infrastructure layer, the engine room, to see exactly how NexusStorage gets its incredible speed.
Just look at this comparison. It's a night and day difference. Traditional systems are super inefficient, copying data over and over again just to get it onto a disk. NexusStorage, on the other hand, uses this modern Linux feature called I/O urine. Think of it as an express lane for your data. It enables zero-copy I/O, which means the data goes straight to the disk, and it can bundle hundreds of read or write requests into a single, unbelievably efficient command.
But performance isn't just about speed, right? It's also about protecting data efficiently. NexusStorage uses a technique called erasure coding, which lets it lose multiple drives without losing a single byte of data. The catch? The math behind this is seriously complex. The solution? Using something called SIMD instructions. Here's the best way to think about it. Instead of a calculator solving one problem at a time, SIMD is like having a supercomputer right on your CPU that can solve thousands of problems at the same time, making the whole process just incredibly fast.
Okay, for all you developers watching, here's a little peek under the hood. This C# code is using hardware intrinsics. Yeah, it's a fancy term, but what it really means is that it's talking directly to the CPU in its native language. This lets the application tap into the raw, parallel processing power of the CPU's SIMD features, which just massively accelerates those calculations.
Speed is awesome, but it's totally useless if your data isn't safe. So let's take a look at the features that really turn NexusStorage into a digital vault.
So here's something crucial. Hard drives don't always fail with a loud bang. Sometimes, bits just silently flip over time. It's a real thing called bit rot. NexusStorage has a scrubber service that is constantly, quietly working in the background. It rereads every single piece of data and compares its hash to the original one. If it ever finds a mismatch, it just uses that erasure coding parity to automatically heal the data on the fly. Now, how do you make sure that all the servers in a giant distributed system are playing by the same rules? NexusStorage uses the Raft protocol. You can honestly just think of it like a board of directors for the cluster. It makes sure that when you, say, create a bucket or change a policy, that decision is officially recorded and agreed upon by a majority of the nodes before it actually takes effect. This prevents any kind of confusion or inconsistency.
A storage system is only as good as its ability to grow with you.
So let's check out how NexusStorage is built to scale not just up, but out in a bunch of really flexible ways.
This slide really lays out the three-pronged approach to scaling. You can scale horizontally, which means just adding new server pools to your cluster. You can scale vertically by simply slotting more drives into the servers you already have. And maybe the coolest part is the hybrid scaling, where the system is smart enough to automatically move your less used data from your expensive fast SSDs to cheaper high-capacity hard drives all by itself.
So, we've covered performance, durability, and scalability, but that's not the end of the story. What really makes NexusStorage special are the advanced, next-level features that are baked right into its DNA.
This is an absolute game changer, especially for anyone working with AI. Imagine this. Instead of searching for a file named dog.jpg, you could actually search for a photo of a golden retriever playing in a park at sunset. NexusStorage can actually understand the meaning inside your files, creating a mathematical representation of them. This lets you search by concept, not just by keywords.
For industries like finance or healthcare, data retention isn't just a suggestion, it is the law. WORM, which stands for Write Once, Read Many, provides a compliance-grade lock. Once you set a retention policy on an object, it is physically impossible to delete or change it, even by the root administrator, until that time period is over. Okay, so what if you have data centers in New York, London, and Tokyo? How do you manage all of them without a massive headache? Well, the global namespace feature is the answer. It stitches all of those separate clusters together and presents them as one single unified system. Your applications just see one giant pool of storage, and they don't have to know or care where in the world the data actually lives.
And of course, to control all this power, you need a great command center. NexusStorage has this sleek, modern dashboard that gives you a live, real-time view into the health and performance of your entire cluster. You can see everything at a glance, from the health of one single drive, all the way up to the I/O of the entire system.
So, when you put it all together, a clean architecture, cutting-edge tech like I/O Uring and SIMD, and these incredibly intelligent features like vector search, you get more than just a storage system. You get a true platform for innovation. The real question this leaves us with is, as this level of power and intelligence becomes the new standard, what will you build on top of it?